Hello, everybody. This is CUDAN Open Lab seminar on November 21, 2022. Lots of twos in there. And today we have Ágnes Horvát, who is a professor at the Northwestern University, also the School of Communications, the Northwestern Institute of Complex Systems, and the McCormick School of Engineering. Which all has to do with our board member, Julio Tinho. And Ágnes Horvát also is one of the first faculty worldwide who actually taught a course titled Cultural Data Analytics, I assume. As we all know, it's not so easy to get these kind of courses into course programs. And there, Northwestern was first with you. Ágnes has a background in network science and also physics, and she will talk today about science on the web, how networks bias academic communication online. And we're very much looking forward to that. And we have a 2-hour time slot, so basically you can speak as long as you want, take questions in between or take questions at the end. Our ideal is always 40 plus 80, so 40 minutes presentation, 80 minutes discussion or so. But as I said, you can sort of pace as you like, basically. Stage is yours.
Excellent. Thank you so much, Max. This is such a pleasure, a treat to be with you today. And you mentioned the cultural analytics class. That's very close to my heart. This talk will not have that much of that sort of material, but as you mentioned, there's ample time for discussion, so we can deviate at any time. Another heads up about the talk is that the way I currently prepared it is very much data-driven. It's very much graphs, plots. So we will get to the empirical stuff first, but throughout I'll try to throw in some more theoretical questions, and we can have a discussion about those afterwards. I think that's super exciting. So the talk will deal with a topic that I got into a few years ago, namely how science is communicated on the web. Partly this communication comes now from scholars. I think it's really neat how some of the new media forums have enabled this communication more more so than we would have thought. A lot of people are using platforms that have not been developed for science communication per se to disseminate their scholarship, promote their work. And I think that's very exciting. It doesn't come without caveats, but it's really interesting to me to see how certain publications, certain folks are. So this is the space we are going to talk about. Just to set it up on the on the more theoretical front, when I'm thinking about where science is today, you know, with all the pandemic-related changes, with some of the changes related to how politics have changed recently, I cannot help but think about the study that's actually now a seminal study that's actually now 30 years old. I'm talking about the paper that came out in Futures in the 90s by Suntovitz and Travet. And they already then were talking about how maybe we might have entered a new era for science. And the old era for science was the normal science, the way we got exposed to it maybe in elementary school, middle school, high school, that was very much driven by curiosity, was very productive, where we were challenged to solve problems and think creatively about some of the key questions in physics, chemistry, biology. What I argue is that actually maybe we've reached a new era that they call post-normal science is really different. Where individual curiosity is not at the center, but at the center should be problems that are on the one hand related to uncertain facts, Some of the values might be in dispute, and the stakes are typically high. We have to make decisions urgently based on some of those uncertain facts. And this is an old paper, a seminal paper since then. It had a lot of criticism as well, but it was interesting to me to see how in the last couple of years it got picked up again. And some of these ideas around the importance not only of the scientific community, the extended peer communities became front and center. How we started to again about the need to diversify and democratize science, and how we again started to pick up this idea of how we think about science quality control. These all again became a very important dynamic and some of the recent developments. And as thinking about this, my work also recognized some of the trends that have changed. Obviously, we have not stopped thinking about these ideas in the 90s, but a lot has changed in terms of the opportunities to study how science is disseminated on the web. And I have here just a few statistics. These are certainly not the most up-to-date numbers, but we see increasing numbers of researchers use some type of social media for the dissemination or promotion of their work. In tandem with that, large parts of the population, I have here numbers for the US, but the same holds for Asia, the same holds for Europe. Large part of the population will talk about online platforms as primary sources of science and information. And in parallel with this, also journalists will use social media to understand and represent opinions in news. So there's this this trend that will not be unfamiliar to you, where all key actors are more and more heavily relying on online platforms. And yet, despite the fact that we know that this is happening, and there are studies 10 years ago that mention how this is increasingly important, there is an increasing recognition that we don't know empirically how this pans out. And this is, I think, a real opportunity for those of us who are very much on the data science side, who are interested in actually getting at those numbers and understanding through those numbers how this is in the wild. So with these new trends and these old ideas in mind, my research asked the broad overarching question: can networks of the spread of scientific articles on online platforms be used to improve science communication for two stakeholders? On the one hand, for researchers, but then also for society. This is a really broad space, a really broad idea. And I've been on it for, I don't know, 4 years now. I settling at the answer possibly yes. And then through some more specific research questions, I'll give you a sense for why I'm saying possibly yes. So in the past few years, we have structured the projects that just seemed really necessary to tackle in this space into 3 groups that I'll try to cover. And again, depending on time, we can negotiate on the last one, or we can in the second one. But the first idea that seems to be very well supported empirically is this idea about social biases in the visibility and the impact of knowledge. So when we look at how science is disseminated, the first that is quite striking is that there is a gender bias in dissemination. And in addition to, and I'll show you this in detail, the first thing that we did was to quantify this gender bias area. In addition to quantifying this, we started to think more carefully. One thing we saw was that there was a gender gap in self-promotion, which is one of the factors that might lead to a bias in dissemination. And then as we continued this project, and this is the last one that's ongoing work, we also saw that over time, actually, women are starting to do better and better, but the same does not hold for teams that are not just gender diverse, but also ethnically diverse. And that's an interesting space. I'll talk to you about the details of these projects. In parallel with this, I'm very interested in um, how potentially harmful science is shared. We will talk here in particular about retracted articles. I'll also talk a little bit about the process. It's not always clear how this looks like, and it's of course different in various journals and in various settings. But what seemed to be very understudied is how these retracted articles are shared online, and our work has filled the gap by describing how online attention changes and looks like after publication, way before retraction, but then also after retraction. And then we also looked at who was engaged in the sharing. Potentially they have better interventions. And then just more broadly, older work of mine has looked at the temporal trends and the structural patterns, so the networks behind how articles are spreading online, so how science is shared online. And here I just brought you very new research that looks at the information loss process. So how does content change when we share science across so many platforms, across longer time frames? So this is the outlook for this talk. Again, feel free to ask questions, jump in so that we can dive deeper in some parts and maybe glance over the parts that are not as exciting. So I'll start with the first space, the question around gender and ethnic biases, and I'll set the stage for that by showing you some of the research that has shown gender and racial inequalities, racial and ethnic inequalities in science. This is based partly on older papers, but relies heavily on very new research as well. So increasingly now we have the ability to look at this problem at scale. And this has shown in various areas. Some of these you'll see are from astronomy, others from economy, others from computer science, and then some even try to have this very interdisciplinary or not interdisciplinary lens that incorporates multiple disciplines. So the disparities have been documented in terms of resources, in terms of earnings, authorship applications. In some areas, the revision process seems to be longer for women. The same revision process might be more complicated for ethnic minorities. The standards for publication have also been raised as one factor where women in particular might be disadvantaged. We know there's a broad literature on citation inequality. Similarly, in terms of visibility, speaking engagements have been shown to be more high profile and majority groups. And then all these unsurprisingly feed into something that's seen at the promotion level. So more majority candidates in science are promoted to senior levels. So this is just to say that there seems to be an inequality in terms of visibility that then inevitably translates into inequality in recognition. And this inequality in recognition has been observed a long time ago. I just want to point out one seminar again from the 90s that introduced the idea of the Matilda effect, where this is just in parallel to the Matthew effect. If you are familiar with this, the Matthew effect is an older concept that shows that more prominent researchers get more credit for their work. The Matilda effect is trying to say that women oftentimes are not credited for the same results to the same extent as men would be credited. So there are some interesting examples throughout history. If you can think of Rosalind Franklin, but there are some others as well. Now, why is this important? I will mention just two anecdotal examples. On the one hand, we know from research on heart attack that for the longest time, women were mistreated for this particular disease because simply we did not know that the signs of heart attack are different. The symptoms are different than for men. And just to understand how could this have happened, the literature has pointed out two things. One was that women were not involved in the research, designing the research. So we had more scholars designing this research, then potentially this could have been avoided. And then also in terms of the subjects, the research subjects, women were not equally taking those roles on either. Now, this was an anecdote and a very recent piece in Science by Koenig et al. Showed that this is happening at scale. They even have an estimate for how many thousands of topics we did not tackle because there's not enough women to do that sort of. Very similar research on the racial ethnic side. So this is again one example. When it comes to bypass surgeries, oftentimes we see in the numbers that Black communities have a recurring rate, a higher death rate, because again there's this disconnect between what the patients experience and what the providers can offer. And again, this is something that in terms of the topics that these groups investigate can be shown at scale, and this is increasingly known to be a huge problem. Now, this social justice problem is quite persistent, despite the fact that for the longest time we've had evidence for the fact that gender, racial, and ethnic diversity in science are beneficial. And just to cite a few studies here, research has shown that female members increase the overall team intelligence, that when we have gender heterogeneity on the team, then the team is more creative, it produces higher quality science quantified by citations, and the same can be shown with slightly different data in terms of ethnic diversity. So the ability of these forms of diversity to use bias is an important plus that has been documented over again, and yet we see the difference. So my research comes in here and asks the question, how do we address then the gap in recognition? And this points to the fundamental role of understanding bias in the visibility of scholars. And online spaces offer us that opportunity to quantify the gap in visibility better. I argue, based on research, that visibility can have a downstream effect on citations on the one hand, or the citation piece has been shown a number of times. Our data showed it out in a while. So, and then awards, that's a little bit of a leap, but certainly you cannot recognize what you are not aware of. And I think that part of the problem is that that there's this lack of awareness, which potentially online communication could mitigate. There were arguments not too long ago to say that these online digital spaces can alleviate some of the known gender disparities in academia in particular. And my work, so the research, the empirical research, seem to show that that happens only partly. But there are some, again, something that I will based on this. So I will argue that the study of online visibility, this form of success, it's not a non-traditional form of success, but it is critical to addressing the gap in recognition. And I'll show you what the results look like in terms of visibility, and then we can talk about how that might eventually help with the problem. So let's, unless there are questions about the setup, let's get into now to start about talking about data. So the main data source is from this platform called Metric that you might have seen, the colorful donut on some of the browsers that you're using. Through working with this company, we access data that, I mean, an example is shown, the browser view here, but access quite a bit of data. I'll show you the exact years as well. But what is pretty neat about this is that it is on these time series online mentions for various platforms that might be of interest. Twitter is one example, Facebook, the news, blogs, but then also things like Reddit, things like YouTube, and so on. So we have a number of platforms. We have data on a number of users posting research about posting comments, discussions about scientific articles. We combine that for this particular project with data about historical co-authorship. So I'll argue why we need that in a minute, but we want to make sure that we have a comprehensive view, and for that we also get data from the academic society, but then also from Web of Science to understand the impacts of citations and broad research is very important for Web of Science. I can talk more about that setup, but these three key pieces enabled us to create a data set that will lead to hopefully more insight. So the first thing that I'll present as a result is an answer to this question: how well is female scholars work represented online? I'll start here with a plot for 2017. So just based on this, I'm not showing you the population for which we could not establish gender. We had a very conservative cutoff, and the identification was based on the first name. Not everyone uses their full first name, so that led to some observations being ignored in this plot, but where the name was quite suggestive of the binary gender identity, here we use that. And you'll see here that a little bit over half of scholars from psychology who are visible online are women. This goes down to 44% in medical sciences, 40% in the humanities, same in biological sciences, and all the way down to 20%. So just the percentage of women in online science dissemination. Now we compare this with the percentage of women who are publishing in those areas. Web of Science enables us to look at the full sample, not just the ones who had mentions online according to Altmetric. And what we see is that across the board, so in all areas, women who have their research online are fewer than the ones who actually published. And this is quite different in chemistry, so almost 7% point difference there, and not so bad in the humanities, a little bit over 1. This very simple frequency analysis is that there seems to be what the literature calls a glass ceiling effect. If you look at the top row here, the data points for psychology, I don't know whether you can see it. The salmon-colored bar is the percentage of women in the Web of Science, and then as you move to the left from the 54%, then you see that we have a lower percentage in the top 25% of women, so top 25 visibility. In the top 15%, we have even less. In the top 5, top 1%, less than that. And this is something that's quite consistent. If you see another good example is biology or the social sciences. It doesn't check out in every field, but by and large, we see that there is this glass ceiling effect. The higher you set the bar for the success category, the success level, the fewer women have amongst scholars in the success category. So can we then model? Can we understand what explains online success, online visibility, and how does that differ between the men and women in our data set? And as we did the research for this, we saw literature that was not surprising in terms of linking scientific impact with success. There's quite a bit of research in scientific that shows that. There's also research talking about how social capital is important in determining success. These papers don't talk about visibility per se, but success in more general terms. And then there's also research showing how gender type formation in collaboration, whether you work with other women, you work with men, or you work as a man with men and women. And just to indicate that there are substantial difference without even any quantification, just eyeballing these. I'm showing you here 4 example random scholars in medical sciences. You see on the left side the women, on the right side the men, the top panel, the successful scholars, those who have visibility in the top 5% and in the lower part, those who don't have visibility in the top 25%. So you just see that there are differences in terms of the size of the networks, in terms of the interconnectedness, in terms of the structure, and these seem to be there both for men and for women. So based on these prior observations in literature, we had quite a few, and then narrowed it down to those that were most linked with online visibility. And in addition, we grouped them in 4 groups just to mimic this focus in the literature and to do a PCA that enabled us to have lower, less randomness, just more consistently. So I'll talk about that, but I'll talk about this as we build the final model. But again, I can some of the intermediary steps that are potentially interesting. So we had the feature group around scientific impact. Productivity, the number of articles in the past 5 years was one factor here. Traditional success, so the H index in a given year, this is one of those measures that you all probably know as something that you have to increase if you want to get ahead in your careers. The impact factor of the journal where you published is also one of the more expected ones. Was a high impact journal, and here we coded high impact as Nature, Science, PNAS, following some of the scientometrics work. It works with slightly different coding schemes as well. And then another thing was whether you were working in one of the hot topics. So to identify the hot topics, we looked at the data. We didn't have an external data set, but we looked at the top 20% most highly cited or mentioned research topics, things related to cancer, things related to AI fall under those. So if you are in very interesting, highly visible space by these standards. The other features were, the other 3 groups were the groups around social capital. So how many collaborators did you have in a year? What was the density of your ego network, your collaboration network? What was the average team size in the past 5 years? A little bit of social capital in the past. And then we had just very similar features to quantify what we call here network femaleness, network maleness. So how many articles did you have in female/male majority teams? How did the homophily look like? And what was the average women? So if we look at the results now, in terms of these four groups, the first thing that you see is that across the board, the data points for men, the green data points seem to be to the right of the data points for women. These are models ran for a separate research domain. The explained variance ranges from 0.15 to 0.31, which is in the social sciences not bad. Of course, we have quite large samples, but the regression, the binary regression or logit regression, are you in the top 25%? Not. But by and large, what we see is that when it comes to factors, just to take an example, agricultural sciences, the social capital variable. For men, it is the more social capital you have along the dimensions mentioned, the higher the expected online visibility. For women, again, in agricultural sciences, the higher your social capital, the less expected visibility. This is a strong, strong example. Some of the other ones are less stark. But in general, the main takeaway I would say is that all four variables seem to be quite strongly correlated, positively correlated with the success of men in these research areas. When it comes to women, then the coefficients are either not significant or outright negative, or in some of the cases where they are positive and significant, they are less so than for men. And this was quite consistent regardless of the method used or the specification of the model. We did see this quite systematically. One thing that I will note here is that I will go through some examples, but for this particular model, the humanities were just not big enough to have consistent models or overfitting that we can look at area where we know there are quite a few women, and yet when it comes to the importance of these factors, it's only scientific impact that is positively correlated with the visibility of women. When it comes to social capital, non-significant. Network femaleness is also non-significant. Maleness is actually negatively associated with online visibility. Another example that I can point out here is engineering, where scientific impact, social capital are non-significant for women and are negatively associated with the visibility, online visibility of women when it comes to the femaleness, maleness of the men. And this is striking, right? Because what this tells us is that based on these results, we can devise strategies for men. We can say that yes, all these things that we know from traditional success literature should increase your online visibility as well, and then further increase your offline success. But when it comes to women, it seems like we just don't know what to recommend. There are no clear strategies. So what the literature might have suggested that working with men, so the majority, just minority working with majority and benefiting from their success or their visibility does not seems to translate here. So we cannot even give meaningful suggestions. And I think this was quite sobering. On the more positive note, when we looked at the population, the differing populations, men and women on these platforms, we saw that those who were successful had just very unique strategies to get there. So that didn't translate to these traditional literature-based factors. So I think it's interesting. I think there's from the next project we will have more positive results, but this research did seem to suggest that on the one hand we have a dramatically lower visibility for women. On the other hand, we just don't even have a clue how to improve that. And I think that's an important lesson for those who think about science evaluation. Now, where do these disparities in visibility come from? And if you think about it, there are at least two main things that come to mind immediately. One of them is self-promotion, women self-promote less. And the other thing could be biases in sharing, solely out of their hands, where the community just doesn't equally share the work of in space. Now, I'll talk about self-promotion here. It turns out that I'll walk you through some again, interesting empirical results. It turns out that factors might be at play here. The differences in self-promotion will be stark, but they don't fully explain the differences in online. So let's see this self-promotion thing. We have a bunch of literature to suggest that there will be differences in terms of how visible or in terms of how ready women and men are to self-promote. There's literature in psychology on the fear of backlash. So when women engage in behaviors that mirror stereotypes, they typically get a backlash. This might be the case when they self-promote online or offline. So there's a literature on that. There's literature on self-stereotyping. Women might have gotten used to the idea that that's not expected of them. And then there's interesting literature on the imposter syndrome, which is has been documented for younger scholars, especially scholars who come from backgrounds that are not necessarily tying them to academic circles. And there's literature suggesting that this might be stronger in. So these three are at least, these three are certainly factors that could explain this, but how does this look like effectively in the wild? And when we look at this I'm showing you data for 2018. This is data that is part of a study that we did a year between 2013 and 2019. So this is just one of the years. However, one disclaimer here is that we could only do this for Twitter because the way we detected self-promotion was that the Twitter handle of the author showed the mention of their paper. This is, it sounds quite straightforward. It's not so easy to implement, but it's at least one context where we can point to self-promotion more reliably than in other contexts. And what I'm showing you here is that overall men self-promote 22% more often than women. These numbers control for journal impact, the prestige of the affiliation, the rank of the institution where they are based on one of many external rankings, and the productivity. How many papers do they have? And to expand on that a little bit, I'm showing you three graphics here that all show the predicted self-promotion probability. On the journal impact factor. So if the journal impact factor is rather low, then there is a gap between men and women. Both of them self-promote more if the journal impact factor is higher. But we see that men self-promote, the boost in self-promotion is higher for men than when we see this diverging plot. We see that in terms of the affiliation rank categories, so in terms of where the institution, how prestigious the institution is, where they are, or how central it is, doesn't have an impact gap. The lower the prestige of the institution, less people self. An interesting pattern that we observe is in terms of the expected numbers or expected rate of self-promotion with respect to the number of papers. And it turns out that someone has just very few papers, self-promotion is low, regardless of gender. This is higher for people who come into the publication game, and then it's lower again as people. So these are interesting trends. Regardless of the gender component, I don't think anyone has looked at it empirically at that scale, but then there are these interesting gender components as well. So when expanding this research, we did two more things. One was to connect now online visibility with citations. So what we know from how science is evaluated is that people don't stop at visibility. People want to talk about citations. Citations are, in many ways, an imperfect, but certainly the standard way of evaluating science. So in these models, and to briefly summarize it, we look now at the full pipeline. Something was mentioned online. It got some visibility, and then how many citations did that translate into? So we look at mentions in a year and then citations in the following year. We have some different citations per club, and the results are quite consistent with our here. This is a plot where I include explicitly changes over time because they are really, really interesting, show some improvement. And then another thing that I include here is we don't only look at, this will be not at the scholar level, but at the team level. And we look at gender diversity, so the fraction of women on the team, but we also look at ethnic diversity. And the way we conceptualize ethnic diversity, I don't know whether you have thought about this. There's one tool that the community seems to be pretty excited about, NEA API, that's able to, again, based on the name, which is imperfect in many ways, based on the last name and first name, it sends people to one of the 9 groups, major groups, and then many subgroups. A major group here is a British origin name, a Northern European name, an African name, Chinese name. So there are some interesting groups, interesting nuances. What this will not tell us is whether that person with a Chinese name lives in the US, that is in that environment, so we cannot differentiate nuances, but we can look at the name-based origin of these groups, and based on that, we use a standard measure, the law index, to quantify ethnic diversity. This is just telling us how likely it is that 2 names on the same team are from different groups based on these 9 overall categories. So let me show you the results. So first thing that we see is that online visibility is strongly associated with citations. So what this model is telling us is, again, a logic model. Are you in the top 25 or not? But this time based on citations. So what we see is that online visibility is clearly and strongly associated with citations. It's becoming more and more important. Another thing that we see is that while back in 2013, having gender diversity in the team was not significant, now in 2019, this was a positive, significant factor in determining citations. Ethnic diversity has a varying positive effect. So if we are looking at the trend here more, it seems to suggest that recent years have been a smaller positive effect. When we intersect, however, gender diversity and ethnic diversity, so the teams that have both, then what we see is that this combination leads to lower expected citation. And this is worsening as the year. I think this is something. Sorry, hold this, the intersection panel that we are still working on. So just to wrap up this part and this piece in particular that expanded on the idea of underrepresented groups in science. So we have both gender and ethnic diversity. We see that teams with high gender and ethnic diversity are cited less than homogeneous scientific groups, even if they have the same online visibility. These trends have been evolving. I think some of the changes over time are really interesting. So gender is no longer a negative factor. Ethnic diversity is becoming less positively influential, and intersectional penalty is getting worse. What we take away from this, and again, this is work that we are writing up now, is that scientific institutions need targeted strategies to promote the work of diverse research teams, because the community does not seem to be as likely to cite them, regardless of the self-promotion data. Now, oftentimes when I talk about this, women in the audience or underrepresented minorities in science in the audience, oh, this is really bad news. And I think it's a matter of perspective. I have done work, and many others have done far more work outside of science to see that things, of course, these are not comparable, but things are actually worse when it comes to entrepreneurs and worse when it comes to entertainers. So I think this puts things into perspective, and I think it's telling us one thing to understand the science, another thing to try to tackle it outside of it as well. Now, this is a breaking point. I have here a second part on how a form of science misinformation is circulated online. I'd love to get to that, but I want to check in with you, Max. How are we doing on time? I don't see it here. So I took quite a bit of time to explain the gender bias component and ethnic bias component. So sorry about that.
No worries. Sorry, I switched on the wrong microphone. No worries. So it's 10 minutes to the hour, so we got like 70 minutes or something. But like if you have more to present, we could either intersperse some discussion here and then continue back to the presentation, or we could take questions at the end. But maybe there is some immediate questions. So I see Yuna is raising her hand behind me.
Yes.
Take it away. Yeah, then I switch off this one. No, don't. Okay, just speak up.
Can you hear me? Is this?
Yes, perfect.
Oh, okay, great, sorry. Hi, Agnes, and thank you so much for the exciting first part of the talk. This is very interesting for me personally because a lot of the work that I do is with gender inequality, but mostly in film and TV, basically media production. I was really interested to look at your slide on diversities and different effect that different types of diversity have on publications. And I was actually wondering how you measure the diversity here. Was it just the percentage of, let's say, the minority group counted, or was there another measure? And maybe on the same slide is another question. How do you derive this name origin-based ethnicity? Do you use a specific algorithm for that? How is that like practically done? Thank you.
Yeah, those are excellent questions. And if you want to do this type of work, it's something that you think about quite a bit. The approaches to this out there are all imperfect, but there seems to be a consensus about which ones are best. We've aligned our research with the best and have run some controls. Ran some controls, and the results seem to be unchanged. So to answer the two questions, the diversity measures here, gender diversity on the theme was simply the fraction of women. Again, this is based in this idea of binary genders that is imperfect, but it's still the best approach we have there. In terms of ethnic diversity, the measure was something that is called the Blau index, which quantifies how likely it is that two people on the team are from diverse or from different ethnic groups. This is one of those measures that's again imperfect, and we know that the ethnic relation is dominated in science, is dominated by two groups, one of them being the British origin names and the other one being the Chinese origin names. We ran controls to see whether if we put in the percentage of British origin names, so the dominant category, then we get similar results, and qualitatively these are all, I mean, you can hardly see any difference. So these are excellent questions and something to think carefully about when talking about things as sensitive, ethnicity, and gender. And again, with the recognition that these are not perfect, whatever is out there and being used does seem to lead to the same conclusion. And note on the detection algorithm, this is called the Ethnea API, and it's the most heavily used tool. Just much like gender identification or gender inference works based on the names and uses records from countries to understand how common a name is in that specific area or in that specific group. So, and whenever, so all of these have cutoffs, how certain it is, the algorithm, how certain it is, and the certainty is something unsophisticated. It's just how frequently this name showed up, say, as a man, women, and if very towards men, in I don't know, over 95% of the cases, then we say, yeah, this is a man's name. And if it's not, then we just unknown group, if that percentage is like 70%, we said no, we just don't have the certainty to establish gender or ethnic group. Well, does that answer the question?
Yes, it does. Just maybe a very small bit to that. When exactly as you mentioned, when the gender or ethnicity is uncertain, do you just have them as unrecognized, or do you ever? Because I see you work with such large samples, do you ever go in and manually try to check and verify, or just have a separate category?
So we have in each of these cases, we had manual verification based on a small sample. So of course we cannot do it. These are, I think we have 1 million papers per year on this plot. So there's just no way we could check this. But we verified or we validate the approaches based on small samples. And then through this conservative threshold, what happens is that a lot of people fall in the unknown category, and then just as a test, we run the analysis on the unknown group as well, and just to make sure that there's nothing weird there. We cannot know why someone landed exactly in unknown. It might be because they have a more gender neutral name. It might be that they just provided their initial. So it's certainly an interesting group, but we look at it and the plots that I showed you are based on the name of the people who can clearly be grouped into men, women, and these ethnic.
Okay, thank you very much.
Thank you. So there is two other questions, one by Mila and one by Mikhail.
Yeah, okay, so thank you so much. This is super interesting already now. So, and very valuable, research. My question, I fear it's very broad and difficult to actually, or somehow, because I'm just interested in whether you have been thinking of what is the relationship between the visibility and kind of like effect of the research in wider in the society, namely, and quality of research, and maybe you have been thinking of these kind of like correlations or whether what is the relationship here. I understand that it is apart from measuring citations, like effect on societies, it can be impossible to measure. And perhaps also quality, but I think that I would be really interested in hearing what are your kind of like underlying assumptions here, and kind of like how you have been thinking about if there is a kind of like relationship here. Thanks.
Yeah, so that's of course a very important question. So when it comes to science, we know that science can have. There are so many levels at which science can have an impact, and part of the problem with the way science is evaluated is that it's so citation focused. So science has always had an obsession with quantifying things, and it landed on citation. So that's why that's so easily captured, because most of the data sets will contain information on it. But you are correct that there are these other aspects to doing science that are essential, and that this will not. Personally, my route to dealing with that is that parallel to this research, and I anticipated that a little bit in the beginning, but I didn't get time to talk about it. What I'm increasingly excited about, and I have been involved with this for over a year now. I'm involved in a civic science initiative, a funding and training mechanism through the Retail and Foundation that I think is doing fantastic work in identifying people early to maybe mid-career people who wanted precisely that sort of science that is more attuned with what communities need, and not only concerned by the diversity of who get to do science and potentially how that translates to more diverse topics, but who benefits from science and how do people who are not academics engage with science. So there are a lot of interesting projects there, and I think that's very different and complementary, necessary approach. One that does not lend itself to the few papers that are out there on diversity in evaluation talk about how minority groups do more service, do more teaching, do more mentoring, but those are also just narrow factors. We want to envision science making an impact in society. So, in short, the answer is since we have no really good ways to quantify that broader impact, it will not show up on a graph like this. I don't see that happening, but I think all of us have a responsibility to try to do our share, to engage in that sort of work. And for me, that's the civic science movement, which I think is very exciting. It's clear whether it will do for science. It's not clear whether it will be successful, but I think that's the closest to how I can envision engaging with communities beyond science and making sure that science is being used more broadly. Does that answer the question? Excellent. I see another raise.
Thank you very much. First of all, it was really very thought-provoking what you told us. I just wanted to ask a couple of rather technical questions. Can we get a couple of slides before this impact of the? Even before that, I think this one. One thing I was maybe you told and I somehow missed it. What is network maleness and network femaleness? How you define it exactly?
So these are not the best terms. I agree with you. But in particular, so you will see here on the right lower corner, the network maleness was the number of articles or network femaleness, the number of articles in female majority teams. The majority here was not above 50%, but whatever the typical fraction of women was in that specific area. So in physics, that was something like 20% or 16%, something around there. So if a team had 18% women in physics, then that was a female majority team. So we just did that. Female homophily was again in the Eagle network. So what was the probability that you were working with as a woman, working with other women, or actually we computed that also for men. So this gender tie formation was captured there, and the next variable looked at how often you do that. So the average tie strength was how often you collaborated with other women, and then in the network maleness, how often you collaborated. So this was just, the two are quite complementary, computing the same things with how often do you do that with the male group and
So basically, my question is, and as far as I understand the answer, well, my question is, I was a little bit surprised that network femaleness and network maleness are not anti-correlated as a factor, but they are both correlated with social capital, yes, in a sense. So if you publish more, both of them go up.
Well, you can theoretically publish and have a lot of social capital, but that's just with other men. You can do that. So there's no need for both to go up. But statistically speaking, you are correct. Like if you publish more, if you have more collaborators, then chances are higher that you will have both groups represented.
Okay. Yeah, I understood that. Thank you. Sorry if I interrupted you.
No.
And the second, basically, just to understand how bad things are, because you said that essentially it looks like the visibility of female researchers, at least in some fields, is essentially uncorrelated with any of these metrics. Let me put it like this. Am I right to understand that if you have one female researcher who published like 10 Nature papers in a year, and another one who published like one paper in some obscure original journal, am I right to understand that their chance to get visible is essentially the same?
Yes. So maybe the numbers are not accurate here, but the scientific impact is not just the prestige of the venues. Scientific impact had productivity, H-index, impact factor, and all those things. But yes, essentially what you are finding is that in this population, what we see is that scientific impact. So for instance, it's for women, it's just not correlated with online visibility. Now, a caveat here. What might happen is that the population of women who are using these online platforms will not have anyone who has published 10 Nature papers. And that's actually very, very likely. So what we see is that the women who are active on social media are younger, are less established, have a lower H-index than men, for instance, which is so interesting, right? So the adoption is very different. The adoption of these platforms is very different for men and women, and then it's very different within areas as well. That's another thing that I didn't elaborate on a lot. So it seems like the social sciences have done a really good job at adopting these spaces. The humanities not. Computer science is also somewhere in the middle. So there are also differences here in terms of adoption. So we don't see the full population, but to lean into your question, yes. So the scientific impact as quantified by those things just does not seem to significantly impact women's success in both of these fields. So in engineering, it's non-significant. Astronomy, it's non-significant. In physics, it's non-significant.
Okay, thank you very much.
Thank you for being so thorough and detailed. Typically, people are like, oh, yeah, yet another gender paper where things are bad. But there's so much nuance there, and it does prompt us to think more carefully about, again, the population, the sample, which is not perfect. It has all these issues, but yet it has these really interesting things where we're asking ourselves, so how do we go from this to an efficient intervention, possibly change it in how we do things? Other questions?
Yeah, I got a question too. Actually, it's a very short question and a hypothesis, which I only provide after. So can we go back to this or forward to this slide that we started that discussion with? Yeah, this one. So there is one dimension or number of dimensions of diversity that is not in this picture, I assume yet, which is multidisciplinarity, right? Which is obvious. You yourself know with a degree in physics, going to communications, that has some kind of effect. If you're a physicist and you change to systems biology, you can basically tenfold your citations and stuff like that. So there is a similar kind of thing going on. One could ask the question, how is it if you combine disciplines and stuff like that? The simple question is that something you plan to factor into your analysis at some point?
So that's an excellent, of course, an excellent question. All of us who are engaged in this know that there's a high potential gain, but a lot of immediate penalties because you just are not familiar with the convention. The one paper that so there are not too many good papers about interdisciplinarity in science of science. Paula Stefan has a really good one that I like, but it's not at this scale, and I don't know the quantification, the good quantification of interdisciplinarity would look like. Because to some, biophysics is, or bioinformatics is an interdisciplinary field, although it has existed for longer than many of the communication in many ways. So it's just really tough to decide how we would meaningfully incorporate interdisciplinarity. I think we could come up with different versions, and it would be interesting to see whether the results show a clear penalty or a clear gain in multidisciplinary research. It would be fascinating to do that research. I know a lot of emerging areas that are at boundaries would be interested in seeing such results. So we are not currently.
So I see. So we're not there. So obviously one could start with the PhDs of people, or inversely, you could start with the content of the publication and cluster those, right? But I think it would be really hard, I agree. So, but let's imagine we would have that data. We would have the gender, we would have the sort of affiliation with communities of society, which may be what's called ethnic, race, whatever, religion. There's all sorts of these kind of things. Now, let's imagine we would have that kind of information explicitly. So the theory of intersectionality, as posed by Crenshaw and Collins with the so-called matrix of domination, sort of is interesting because intersectionality is often depicted as, you know, like a kind of a Venn diagram where the more intersection.
Oh, I cannot hear you all of a sudden. I'm not getting any sound, sorry. I could hear you perfectly until, I don't know, 30 seconds ago. Yeah, I can hear you again. Not sure what happened. Nope. Now.
Is it better now?
Yeah. Now I get the echo, but that was one of those very weird ones where it was clearly working. No. And I'm not getting not even the white noise, the background white noise that's typically there. Nothing. Yep. Now I can hear something. Nope.
Yeah. Hello.
I can hear something. Yes.
Sorry for the sound quality will be now different. Okay.
I can hear you very well, so this is good.
So let me repeat my questions or hypothesis. So intersectionality theory is often depicted as a series of concentric circles in a Venn diagram representing the different, you know, being male, female, being sort of black or white, or, you know, that kind of thing. So that is very clearly sort of a depiction that we're very familiar with of like an overlap network. And now the interesting other thing is the other super highly cited part of theory, Collins, which literally speaks about a matrix of domination. So these two things, for a very long time, I've always wondered if that is something we could enact basically quantitatively, like really take in the literal sense of the word how we use it. And so then asking the question, can we actually draw that matrix? Where there's one really interesting thing going on, which is that diversity by nature is sort of like, you know, heterogeneous, fluctuating, changing, and all sorts of stuff. But oppression, fundamentalism, xenophobia is always very boring and very stable. So the question is, in this matrix of domination, if we see it literally, can we find sort of the, you know, the eigenvectors of awfulness, so to speak, and something that is that we would be able to recover in these kind of things. Like, we all know some natural scientists look down at the humanities, some humanists look down at natural sciences and stuff like that. But is that something which we could really recover systematically from the data and indeed find out, like, if there is a kind of gradient of oppression going on, where there may be exceptions and stuff like that. So you're halfway quantifying this kind of structure in a sense, right? Which is a very hard-won research program, I assume. And so the big question associated with this hypothesis at this point in time would be, do you think this is feasible? Or do you think also in your encounters with audiences and stuff like that, it's just a way too complicated situation to actually grasp it, which is such a, perhaps you may say, crude quantitative tool?
Yeah. So I think what I see is that we can quantify anything, right? So we can put the measure. If we lower the bar on the measure, then we can include anything. And then the question is just given how bad potentially the measure is, how confident we are going to be when making any claims about. So one dimension that you point out here is this interdisciplinarity. I mean, just quantifying that would be quite the effort. Quantifying it imperfectly, I think, would be doable. So we could have the additional factors in the model. The question is, what do we do with it? Because and this is, you are really correct in talking to people. So I've presented this work everywhere from my alma mater. I didn't have a single female professor in physics. And these are the people from whom I learned everything that I know, essentially. And when I was talking about this research, they were like, okay, sorry. So it's just a really interesting dynamic when you start to talk about this and unpack that, and you want to be careful when you do these measurements, especially when it comes to the behaviors that you are pointing to here that are frowned upon currently. So that's why I think it's a really important balancing act. What can we reasonably quantify, and what can we quantify well? I think it's important to just be very careful there. So I think all of these problems, just like in most social sciencey problems, you can have an intuition for, and I think there are no big surprises here in terms of the trends that we identify. But I think it's still meaningful to have good operationalization. So if we would not be able to do that well, then I think this would be a very empty conversation, just relying on stereotypes. So I don't know to what extent that answers the question, but I think it's a really, really tricky space. And I remember when I started to do this sort of research, having a conversation with a mentor and dear friend, and I'm like, I don't want to do this research. I'm just making something that's salient, even more salient. And it's just all the questions around that, and being thoughtful and careful in terms of what kind of results you put up there and how you arrived at those results. So super complicated. I love the question. We should talk more. And I would be interested in particular the interdisciplinary component, which is I think relevant to so many people, because most areas, it's not just physics, it's not just computer science that is trying to get at those new results in a very fast-paced, publication-driven scientific production. Is just, we all hope that interdisciplinarity will give us big boosts, and I'm not sure. So I'd love to see those results quantified well. So we should talk more about that.
Yeah, thank you very much. And so thanks for bringing up the notion of stereotype, which is obviously, that would be the worst result if you would sort of petrify stereotypes by just calculating them out, basically, right? And yes. Yeah, thank you very much. Should we continue with the with your presentation? Like you show us some further aspects. In the meantime, I have a good idea how to fix the microphone. Okay, thank you very much. The stage is yours again.
Good luck and some background content here. Let's talk a little bit now about science misinformation. This is the trendiest way I can frame retraction. I don't know whether you are in environments where misinformation is talked about so heavily. I'm certainly in an environment where people are very concerned about misinformation, and the fewest of them are focusing on misinformation when it comes specifically to science. And one way to move the needle on this was to focus on retractions per se. So retractions are in academia considered science's way to self-correct. So if we see that some results are just wrong, then science, the way it goes about it is that the journal or the community starts to look more closely at the finding. There's maybe potentially a second round of peer review. And there's an investigation associated, and if there are significant concerns that put the results into question, then there's a retraction issue, and this is a big deal. So retractions are not very rare. I think based on the numbers that I've seen across all areas, 4 in 1,000 papers are retracted. These are far more common in certain cases. So in the when it comes to COVID-related research, then according to the Center for Scientific Integrity, they maintain a really comprehensive database. They mentioned more than 250 COVID-related articles that have been retracted by July 2022. And quite a few of these in very high-profile venues like the Lancet. So academic retractions are important. Science communication literature talks quite a bit about their role as they shape the public's trust in science. We know that retractions are quite tricky, and one indicator of this is that prominent journals are actually as likely to publish retracted work as non-prominent ones. So the peer review doesn't seem to guard us against this very well. And retracted research, we also know from quantifications that are out there that retracted research can have a substantial effect on the public's knowledge about science and perception of how well science is doing. So this is an important thing to consider when issuing retraction. What we don't know, or what we didn't know before, I would say we took a close look at this, was how online attention looked like for retracted articles. There was one study that was looking at this at the aggregate level, but it left quite a few questions out there that we tried to answer in this study that I'll talk about next. So the main questions are, what kind of attention is given to retracted articles in online spaces? And the second quite important question with this policy relevance, I would say, or recommendation or relevance for how we do handle retractions. Does the retraction decrease attention to harmful articles? And to answer these two questions, we set up the following rough pipeline. We had from Retraction Watch, so the Center for Scientific Integrity maintains this quite comprehensive database of retracted articles going back decades. We had their data set. We matched that with, we looked those papers up in the Altmetric data set and built a bunch of time series like the ones you see in subplot B. And then we, in addition to doing that, we looked in the Altmetric data set For other papers that were comparable to the retracted papers, we call those control papers. For every retracted paper, we had 5 control papers, and we looked at how those were mentioned as well. We looked particularly in 4 groups, so as opposed to the other project where we just lumped everything together or focused on Twitter particularly, here we looked at 4 different groups of online venues. One was social media, so this includes Facebook, Twitter, Reddit, and the alike. Personal blogs or institutional blogs, so whatever fell into the blog category. News media. We had, again, this very skewed distribution. We had a few of the very prominent ones and many that are probably local news or just reshare press releases. And then we had knowledge repositories. So this was mainly Wikipedia. So on these 4 platforms, if we looked at how much attention retracted work received in comparison to control work after publication, so this is mind here way before we knew that something was going to be retracted, we see that across the board, retracted work receives more attention than control papers. And so this was the first cause for us. This is on the one hand a problem, right? Because this means that on most of these platforms, non-scientists interact with research and they get more, on average, more of the untrustworthy research. And that's probably shaping their views about science and misinforming them. So that's a problem. Now, another thing, if we keep thinking about this, is that probably not every paper that would need to be retracted gets retracted. So visibility is probably a prerequisite to that scrutiny that is needed for something to be retracted. So that's why this kind of makes sense. So visibility is necessary for that sort of intervention that is required for a retraction. Now, the second question that I mentioned, does the retraction decrease attention to harmful articles? Now, the 0 on the x-axis is the time of retraction, and we are talking about weeks, so 2 weeks after retraction, 4 weeks before retraction, just to read the plot. And again, I'm showing you the 4 groups of outlets that we looked at, plus the 5th here, top news, is based on so that's a set of, I believe, 27 news outlets that have a really good machinery, and those are the highly regarded news. And there too, what we see across the board is that by the time the retraction comes, effectively, there's not much attention to intervene on. So here the scales are really low and the error bars are really high. So what this seems to suggest to us is that by the time the retractions are issued, the community kind of knows already that something would need to, or something is false. What the data points that are shown here are the ones that are not talking about the retraction itself. So that's why these are filtered data points. So the conclusion from this, I'm showing you here, and I'm arguing visually. One can do an interrupted time series analysis on this to put numbers on this. The coefficients are not significant, so there's no substantial or significant decrease in attention due to the intervention, that's the retraction here. So essentially, retractions do not curb the online spread of problematic papers. So by the time these are issued, the community kind of knows that there were problems with this. One finding on a more positive note, so after having seen that retractions travel farther, and that the retraction itself does not intervene on this attention, one positive thing that we found is, again, just focusing in on Twitter, article mentions on Twitter tend to express more uncertainty about subsequently retracted papers than non-retracted papers. So there seems to be I do work on wisdom of crowds, and I tend to use the word of wisdom of crowds here, though a lot of the people who are engaged in this conversation are scientists. So what we see is that um, um, there is some intelligence that could potentially help identify flawed articles. So people do question subsequently retracted work more on Twitter than control papers. This is not to say that Twitter should be used as part of the retraction process, but as someone who's very skeptical of social media, I thought that this was a really interesting and quite promising finding. Now, another question related to this is who is talking about retracted articles on Twitter? And again, this is a very simple graphic to show the average number of tweets per article coming from the groups highlighted on the y-axis and broken down by retracted articles, the dark blue, and non-retracted articles, the control papers, the lighter blue. And what you see is that academics tend to talk more about non-retracted articles than retracted articles. The same holds for communicators, but the other groups, and in particular, I'll highlight here the public and practitioners, they are more likely to talk about retracted papers than non-retracted papers. And this is another piece that highlights how important it is to focus on retracted work and maybe do more to signal retracted work also on these platforms, on social media platforms, for instance, that are not likely to point out a retraction. So currently, I don't know whether you noticed this, but currently there's no immediate and easy way to spot a retraction if you are on social media, unless you click on the original paper link and you see that, oh, there's a retracted flag there. So so this is a in the nutshell the retractions piece. Instead of a summary, I will highlight two headlines that I felt covered our research really well. So the key main points were, in Science 2, false information circulates better than good information. So we saw that prior to retraction, more people were exposed to retracted work than comparable non-retracted work. And again, we can talk about why that happens and why that's potentially baked into this process. And the other component of this is that retractions aren't a panacea for bad research. So when it comes to the online, they aren't in terms of the citation penalty either, but when it comes to online spaces and the way the public views retractions, they are doing really poorly because currently we don't have flagging systems in place that would alert the public to, hey, this is actually a retracted piece. And we care about this quite a bit. I hate to go back to the most trivial example, which is the Andrew Wakefield paper that still is being talked about now and has a measurable negative impact on how people, large populations talk about and think about vaccination. Now the last thing, and I think I'll glance over it real quick. This is the thinnest but probably newest part here, where the research question was the following. We know quite a bit now about the bursts that happen in science sharing on various platforms. We know quite a bit about the networks that might be spreading it, but we don't know what happens with the content. And so in this piece that's out there on arXiv, and it's coming out next year in a paper, you can already read it. Let me know if you are interested. What we did was to look again through a multi-platform lens at how science is shared and quantify at scale information loss. And this is a tricky step. I'm happy to talk more about how we did that measure and how we evaluated it with experts. But what we saw, just to focus on the main takeaways before we get into the discussion, we saw that there was a propensity towards information loss over time, even in settings where there was no intent or intervention to misinform anyone, and where people typically, so this is through the sharing trajectories, and typically everyone could have just gone back to the initial paper, read it, and shared it like that. But what we see is actually that over time there was an increasing information loss, so decrease in retained information, and that's interesting. And again, one of those alarming ones. Platforms showed, the platforms that we studied showed significant differences in information retention. Blogs were the best in retaining information. This again talks probably about who the authors of those blogs are. So blogs had higher information retention than news, than Wikipedia, and for sure than Twitter and Facebook, so social media platforms. One thing that I'll note here is that these differences are not simply explained by differences in text length. So that's not, so this is not an artifact of the measure that we are using. And then on the upside, one thing that we observed, and we cannot explain it yet, but it's super interesting in light of the more theoretical work in this space. So those articles that were shared on more platforms, so in the news, on blogs, and Wikipedia, as an example, had less information loss. So what I'm showing you here on the lower plot is that if something was shared on just one platform, then the information retention score on average was fairly low. As the sequences here are burst sequences, so we are looking at that time series. When we had two platforms, then the information retention was higher, but it was highest when we had 3 or more platforms involved. So in this case, if we looked at 5, those were 3, 4, 5 platforms. So this seems to suggest, again, we don't know the mechanism, but I think this is something to look more carefully at. Multi-platform discussions may help maintain higher fidelity information retention. So if something is not just siloed on Twitter, but there are multiple sources of information, then that might lead to higher fidelity information retention. So just to close it off and then open it up for discussions again, I showed you essentially empirical work on science dissemination on the web. It related to some of these questions anticipated 30 years ago and still top of mind now. We saw gender and ethnic disparities in science, how they manifest in visibility, but then also how they manifest in citations. We saw problematic sharing of retracted articles, but we also on the upside saw some signals of quality in the online attention to retracted articles on one platform where we could analyze this, Twitter. And then we saw an interesting information loss in the multi-platform diffusion of articles that again is quite interesting and quite telling about how this dissemination diffusion process is happening even when there are no malicious actors with an intent to manipulate the system. I'll thank the team here. Most of them are local at Northwestern, but I have some wonderful collaborators outside of Northwestern who I'm extremely grateful for. We wouldn't have been able to do this research without them. And for plugs, I have a few things to mention. I know you, Max, you have a very diverse group there. So I'll start with the fact that we have an assistant professor call in my department in computational social science. If you have not seen it, maybe we have not done a great job at disseminating it, but do inquire from me. The deadline is in 3 weeks or so, and this is the position. I mean, it wasn't called computational social science when I joined, but this is the position that or a very similar one that I had, and it's certainly an interesting one. I'm looking for a postdoc in my lab, so if you are at that stage or interested in that, let me know. And this year, I'm also delighted to be director of graduate studies. And so welcoming applications. If you have master students there, we have a program with computer science, and that's a really, really cool one for graduate studies. We have, if you are interested in, and I know you have some folks there, Max, who are doing gender-related work. We have a special issue with the Journal of Computer-Mediated Communication that's on gender gaps in digital spaces. Ask about it. We'd love to see your contributions. And then Web Science is happening next year, and I would love to. That's another task that I'm taking on now. It will be co-located with the web conference. We are welcoming submissions. This is an archival conference, so, and it takes everything related to the web. So think broadly, dream broadly, and why not come to Austin and meet us there. So shameless plugs here. I'll thank the team again. I'll thank you for your patience for the extra long talk. And then let's talk about retractions and how content is lost in online dissemination. I cannot hear you. I think we have an unmute.
Now it works, right?
Yes, now it works.
Okay. So Web Science conferences is if you have abstracts, and web conferences if it's a paper, right? Basically, is that true?
No. So Web Science does have a proceedings too. So if you have papers, we have a short format. So everything between 5 pages, and I should know this, but I don't. So a long paper format goes, and the topic is very, very broad.
So yeah, thank you very, very much for all this bouquet of flowers of really interesting research results. Should we just jump in and like discuss the last 2 points? I think we got like 20 minutes to discuss. If there's no hands up, let me start with one. I'm going to start with the retracted papers one. So you mentioned that in social media, it seems like that the posts about the retracted or future retracted papers are sort of more uncertain. So I'm a big fan of Elizabeth Bick, who is sort of leading the hunt for papers to retract in particularly systems biology, based on what I would say she's definitely in the top 10 of all art historians alive, if you consider these papers artworks. Yeah. So one of the interesting things is that not only do you not have, there's not only the expression of uncertainty, there is actually the elaboration of the identification of papers to retract, which in some sense you need mention on social media in order to have that. And then there is also the backlash happening. So it's quite interesting. She takes the brunt of sort of the irate falsificators, right? So who really are quite threatening. And so one of the interesting things is if you compare this to a world where there is no social media, such as in Germany, the Gutenberg case of the foreign minister essentially sort of like plagiarizing his PhD, which then led to a platform which was called Gutenplug and Froniplug, which then sort of looked at the whole genre of German politicians. Every politician who had a PhD was looked at. But that was genre driven and sort of like, engaged a community. But it is not like one could bring in something that had nothing to do with this kind of A, PhD, B, politician kind of world. So you have this kind of network effect in social media indeed. So did you look at that, or do you think this is sort of like a hopeless thing? Because again, at some point it becomes very qualitative in a sense, isn't it?
So, and it should. So I love the fact that you bring up Elizabeth Bick. She's doing work that the fewest of us would want to do, and it's super valuable. What we see in these online spaces, and it takes quite a bit of quantification, and it already borders on the qualitative component. So to find those uncertain tweets, we again, I'm not an NLP expert, but I talked to NLP experts. How can we do that at this scale? And they gave us a very rudimentary algorithm that produced, of course, a lot of false negatives, but then we had to manually code a bunch of tweets. So the effort that went into that was non-negligible, even though the data was there and tweets are super short. And yet we had a team of, I don't know how many undergrads doing that. So that's interesting, and I feel like it requires that level of rigor if you wanna take the result serious. Going back to something that we've talked about before, so it will have a qualitative element. I don't think when it comes to the very touchy, potentially accusations, you have to have something more substantive that, oh, some sort of algorithm spat out that you are a candidate for whatever. That will not fly. But I think it's very valuable that academic Twitter is providing these signals. And I think that I even went to say that, as far as to say that, well, you know, journals' job does not end when they publish paper. They should, and I don't think they have the bandwidth for this, but they should be more engaged in monitoring the afterlife of their papers to pick up on some of those signals. It's not straightforward how to do it, and it involves qualitative work, careful work. But I think they have to, given how broad the peer review process is. Currently, that's not happening, and when I suggested that, it was actually on the German radio, and they brought someone in, communication scholar, who was like, "That's not going to fly." So there was an interesting debate. Of course, I didn't get to react to that, but that idea of using social media signals to form this process is not universally agreed upon. The other part that you mentioned with dedicated platforms for problematic cases like the politicians, and it's not a German problem. I remember a similar scandal in Romania, and I'm sure there are other places that have grappled with this. Politicians and their very creative PhDs, or not so creative, whatever. But that's, of course, as you say, a very, very narrow setting. I think part of the solution will be those very narrow community-driven efforts. It's not clear to me how sustainable that is, what are the incentives, and how we can solve the problem at scale if we only do those. But currently, there are certain parts of
No hands. So then I will ask you another question for the second thing, the information loss. I think that is super interesting. So ever since the meme tracker paper about 13 years ago, I guess, where, you know, the paragraph is reduced to lipstick on a pig, you have this kind of exponential loss over time. I wondered how good or how much value does it produce for us to actually go to the great length to construct a good abstract, to construct a good title, to construct a good here we show sentence. So in how much does pre-compression of the argument help to actually preserve the signal that you really want to actually get into the audience? Or is it completely different things that people then emphasize?
So the latter. So people, throughout the trajectory, you see all sorts of different things emphasized. And that's, I feel like, the part that's out of our control as researchers who are concerned about writing a good title, a good abstract. I think those, and this is partly the problem, right? So when we write our papers, we write for our community. We write for colleagues who would disagree. I've seen this with some journals that they allow authors to put a tweet, a suggested tweet text, and I think that that's one step further to make sure that you have some agency, because otherwise, yeah, you don't know what's going to happen there, and I think that's one way to go about it, but it's just part of the solution. Not something that will solve this problem. What I find shocking there is that, again, this telephone game component, the meme tracker that you are mentioning, it does seem to work astonishingly, and we don't have a good sense for how bad it is, simply because most existing studies are just sitting on one platform or one segment of one platform. And I think as soon as you start to bring in the complexities of having multiple formats, multiple platforms, multiple affordances, then it becomes really, really difficult. So I don't even think people having the best intentions who read a news article and want to summarize now the content in a tweet won't do a good job, regardless of noble intention. So there's a lot to be said here, and I don't think that we thought about it enough. That we live in these multi-platform, media environments, and when information goes from, I mean, it's already problematic within one, but when you start to jump from one platform to the other, then it's even more difficult to preserve key content. And this is something important for science, because again, none of these platforms have been developed to debate science, but yet most of these are used actively and have this role and function. So unless we can recreate the media ecosystem, which is very unlikely, I think we have to figure out ways to find some signals here and there that could still be useful, or to understand this process and then just more intentionally counteract some of these trends.
Nice. Thank you very much. Any more questions here? Because otherwise, yes, there's a question by the unit.
Yes, thanks so much. Just on the question, I don't know if it's about the first part or maybe all of the parts. It's a question about networks. You use networks a lot of your work, but you don't really show many of the network visualizations. The only visualization we saw was of these ego networks for what I could gather just a single person. I was just wondering, out of curiosity, do you still draw networks when you work with these large samples, or usually just work with network statistics at hand?
Yeah, so that's an excellent question, because of course all of these projects have a substantial network component. At the core, I mean, a lot of the phenomena that we see are so important because networks are involved. And one example are biases, right? So there's nothing better to perpetuate biases than networks, these structural things that are really hard to change. And the same with misinformation. The reason we rarely get to draw these, one, it's really, really big. So this beyond the hairball, or beyond the even filtered backboned hairball, these are really, really huge. So it's very difficult to make sense of structures, and we are not artists. So that calls for the abstraction to convey some meaningful information. So if you ever want to help out, I would really welcome, because much easier for us. So our process is much more focused on let's see how the specific parts of the network look like, so that we can generate those hypotheses that then we invariably test statistically. So we do network visualization in the exploratory stage, but only to look at, just like you said, ego network, or maybe networks 2-3 hops away, to see whether path-related measures make sense. But we rarely get to look at full networks. It seems like a luxury, and it would be really awesome to look at. So yeah, if you want to join forces, let me know.
Thank you very much. So I think this is an interesting thing. This is also a culture question, right? Isn't it? So there is certain streams in network science where visualization is part of the game, and there is those where rigorous statistics is part of the game, and there's other branches where neither of these two are, sort of maybe you could say sufficiently emphasized. And interestingly, I think they're both really hard hurdles to get into, right? In visualization, it's very easy to get into this hairball issue, the backbone issue, and like all the, sort of like geometry is hard, let's put it like that, in the same way that statistics is hard in a different way. And so I think that is a really interesting thing. And I frankly hope both will never go away, because both of them are sort of really interesting and bring things to the table that, otherwise one cannot see. Yes. So this was very, very cool. Next week, we will actually stay with communication. Taina Bucher will give a talk from the University of Oslo. And it's not announced on the web, but I got an email. And that talk title will be Saying Nothing, Saying Plenty, on the role of silence in digital networks. So we're also very much looking forward to that. The other shameless plug we obviously want to do, we will do so increasingly, which is next year we're going to do a cultural data analytics conference, probably happening in December. It's not quite fixed, and we hope that all the previous Open Lab seminar speakers join us in the program committee. So this will all roll out to more people in more official form. So we hope to see you very quickly again. And this was super inspiring, and I think I can speak for everybody here. We will probably follow what you will do in the near future and in the far future. And thank you very much again for being our guest.
Thank you.
Nice. There was the first non-Zoom applause.
It feels really good, and it's not to read a Zoom room. So I feel like you getting together there is really helpful. So keep up the great work. I know that I will share this with the entire team. I remember meeting Max for the first time through a satellite event he organized, and it was the NetSci satellite event. And NetSci is a pretty big conference, but I can speak not just for myself, but everyone was saying that was the best organized component of the entire conference. We're talking about 2012.
I tried to live up to my former self.
Yes. You elevated the standards there. So I'm looking forward to this new initiative you so.
The hurdle is high. Sorry.
That's okay.
Thank you.
Okay. Take good care.
Thank you.
And see you next time.
Thank you. Bye bye.